And the final activity that we're going to look at for this chapter is division with decimals. So the activity asks you to write how many groups word problem for this statement, 23.45 divided by 2.7, and also how many units in each group statement. So I'm going to let you do that. Now, number 2, so I'll let you do that on your own. Number 2, though, says, all right, well, if we're dividing with fractions, 0.25, so 12.37 divided by 0.25, and 1237 divided by 25, those, from our rules before, we know that those two things will be the same. Those two answers will be the same. Because somewhere down there, we know the rule that we move the decimal places over the same in the both numbers that we're dividing, right? And the answer will be unchanged. But why is that? Why is that going to be why is the value going to be the same? Well, the question that this particular activity asks is about money. So if you have $12.37 and you want to know how many quarters are in there, right? How many quarters are in $12.37? Okay. But so that would be the way that you're looking here. But you could also say that it doesn't matter. I'm not looking at quarters. I want to be thinking about pennies. So in $12.37, there are 1,237 pennies. And I want to know how many groups of 25 there are in those pennies. So here we were looking at dollars, and here we were looking at cents. So what actually happened is, as long as we're sticking with we're changing the units consistently, it doesn't really matter what unit we're working in. So for here, we were looking at the fact that these two units were the same. The dollars, we were looking at the dollars. And here, the place values, right? And here we're looking at the fact that those two place values are the same, right? This aligns in the same way. So we're looking at, if we look at place values, we have 1237. If we were to look at the same, to align the place values of the numerator here with the denominator, it would be the 7 is the same place value as the 5, and the 3 is the same place value as the 2. Okay, so the 30 is the same place value as the 20. Good. So as long as that's the case, as long as our values are the same place value, the place value relationship is the same, then it doesn't matter what that place value is, right? Because in this situation, we're either looking at counting in dollars or counting in cents. It doesn't matter. The answer is going to be the same, whether you're counting quarters as quarter of a dollar or you're counting 25 cents and your sum is in cents. So the same thing here with number 3. So if we're looking at 0.06 divided by 0.02, right, we know that if we are looking at hundredths, right, and our smallest unit here is hundredths, that's going to be the same ratio as if we just looked at 6 hundredths and 2 hundredths, right, if we change the unit. So here we would be looking at dollars, 6 cents is $0.06, and here we'd be looking at cents. But as long as we're looking at the same relationship between those two, the same ratio between those two, the number of groups should remain the same. So for example, if we're looking at how many of these blocks are there in these many blocks, right? If we just count 1 in each one of these, this question would be how many 2s are there in 6, right? So that would be this version. But if we wrote that each of the blocks actually represents 0.01, 0.01, 0.01, 0.01, 0.01, 0.01, 0.01, 0.01, there's still going to be 3 of these in every one of those, no matter what each of those rectangles represents, right? So that version is going to be the original division. Well, if we wanted to find how many 2 millions there are in 6 million, that's still going to be the same diagram, except each one of those little green rectangles is going to mean a million. right? And it could represent any other division where the 6 and the 2 have the same place value, represent the same place value, the same bundles. Okay, so what I would like you to do is write out in your own words what the moral is here, and why we're able to do division with decimals the way that we do it.